right, I have also officially started the recording.
Oh my god, depression.
Um, so yeah, this is being live streamed, but yeah, don't be afraid to unmute your mic and talk if any of you want to, or you can also always type in chat. So I see Ghost has a question here. I'll try and answer that before we get started. Just to clarify, the Dapper Wallet API doesn't really have an endpoint to cross-reference what currencies the wallet accepts like Coinbase has. This is because cryptocurrencies that are accepted is an accepted currency to purchase credits on your wallet, really. Yeah, I mean, I think you're right in the sense that Dapper Wallet does not have an API to reference what currencies the wallet accepts. If from my understanding, I'm pretty sure Dapper Wallet only accepts Flow Token, which is like like Flow Token, and also this token called Dapper Utility Coin, which is basically like its way of accepting USD. I'm pretty sure those are the only two tokens that are accepted. And I can actually write that for you in chat. So the two contracts are Flow Token and Dapper Utility Coin.
Just ask a quick question as well. I'm here with Gosu. Gosu's the CTO of Presend, and I'm the CEO of Presend. We just have kind of like a targeted. This is where they asked us to show up to, basically, to ask these questions. So we talked to, I believe it was Carter Paran, and he came to us because Presend basically stops cross-chain transactions from happening. And he was like, hey, could you develop this for Flow? Because apparently customer service keeps getting all of these people hitting them up, users, customers, saying, hey, I lost my Flow token because I sent it in on the wrong chain or into the wrong wallet or whatever it may be. So he kind of asked us, hey, could you develop this solution for us that stops those cross-chain transactions from happening, either going into or out of the Dapper wallet. And I think what he meant was coming into the Dapper wallet. So I guess that's kind of what we're trying to figure out is there like, we were going to participate in the hackathon. Obviously, that got pushed off a little bit and stuff like that, and we were going to bring this solution during the hackathon. Is there like a specific team that we could talk to about this? Because I kind of asked Carter that, and he was like, yeah, the better question would be to go to the developers and ask them who you should talk to.
Interesting. Yeah, I actually don't work on the Flow team myself, but Luke, I'm assuming, like, is there a Dapper Wallet team that would be good for this type of question?
Yeah, definitely, Drew. We can help. I think the best thing, Drew, is for us probably just to talk in DMs, so we can do it that way. So I'll just send you a friend request now. I'm El Dumbo, hashtag 2270, but I'll drop you a message as well. It will just go to your spam folder on Discord. We can definitely get you in touch with at least a point of contact on the Dapper Wallet team. And on the hackathon front, there should be some more updates coming soon. So I might be able to share some news there with you as well to help you kind of inform the decision there. But I think it should be easier just to do it in DMs just so that we can kind of welcome async throughout the next couple of days if that works. Does that sound good, mate?
Honestly, that would be awesome. I appreciate it. And yeah, I went ahead and accepted your friend request. So I won't hijack the floor any more than I already have. I know you guys want to get started. So thank you very much, man. I appreciate that.
Of course, thanks, Drew.
No, not hijack my order. That's a great question. What a way to kick it off. But I will get properly started. And Drew, please just hit me up with any questions you need. And that goes for anyone. If you're listening and you want to ask a question, but you don't want to speak, or you don't want to listen to Jacob, or whatever, DM's always open. Please don't hesitate. Right, for everyone else, welcome. If you're not aware, this is the Flow community-led developer office hours. We will be talking about any and all topics that you guys want to talk about on Flow. This is for the community, by the community, with the community. Myself, I do work on the Flow team, and that's kind of what all I'm doing here is just introducing and then letting you guys run the show. So as you're listening, if you've got any topics you want to talk about, feel free to bring it up. If you're thinking, hey, in the future, I would love to see them cover a certain topic, let us know. Just reach out to me DMs, let us know in the chat, and we'll get to helping like plan that and figuring out how we're going to do that in the future. If you're not aware, as you're listening, you can just simply click unmute and sort of ask a question, or you can hover over the developer office hours channel name at the top, and there'll be a little chat box. You can open chat, and you'll be able to type away there as well. Me and Jacob will be watching both the chat and listen out for any questions as they come in. In today's session, Jacob is going to be covering, I'm definitely mispronounce this, asynchronous multi-signing, which is a bunch of really cool stuff related to treasuries, signers, and all these fun things that I'll let him get into in a minute. He will be recording this as well, so afterwards it'll be a recording that lives on YouTube if you guys want to listen to it after or send it to a friend. And once Jacob wraps up, I'll be sort of kicking it over to a couple of other people if they've got anything they want to say. And then we'll just have at least 20, maybe 30 minutes of open floor time for any and all questions that you guys can ask about building on Flow. So you just saw questions from Drew, you saw questions from Gosu, I believe that's how you say it. Questions like that are all welcome, absolutely. If we can't help you now, we'll find a way to help you. And if we can help you now, we'll help you right away. Jacob, I'm going to kick it over to you. Are you going to be sharing your screen?
Yes. I will share my screen right now. It always cracks me up, Luke, when you when you start stumbling on the technical terms. It's awesome. But thanks for the
any technical terms trips me up, literally any.
it's so funny. But anyways, thanks Luke for the intro. So yeah, so I'll kick it off. And like Luke was saying, I just want to reiterate that like even though this is sort of like a presentation, you know, anyone's more than welcome to unmute your mic or talk in chat or ask questions. It's totally fine. So what I'm gonna
Just quickly, sorry.
Yeah.
For anyone not aware, Jacob has started streaming. So if you look on the Discord app, you'll see by his name. If you hover over his name on desktop, you'll then be able to click watch stream. On mobile, I think you have to like click the little icon and it will let you click watch stream. Just so people are aware, you can now start watching his screen.
That's a great point. Thanks again. So yeah, so today I'm going to be talking a lot about how to I'll try and say this in an easy way, how to coordinate you know, signatures on chain. And I guess the use case for this and something that I'm actually working on right now is this idea where, you know, you want to execute certain actions inside of a DAO, let's say. For example, minting tokens or transferring tokens, or you want to destroy tokens inside the DAO, but there should be multiple people having say over this sort of treasury, right? And the idea is that, you know, we want to get multiple people to approve or disapprove of certain actions, such that if it ever reaches a point where enough people have said yes, the action goes through, or if enough people have said no, the action is declined. But, you know, the main question is how do we actually get, you know, how do we coordinate multiple people to, you know, say yes or no asynchronously, right? So that they don't all have to sign one transaction to say yes, or all sign one transaction to say no. They can individually send transactions to vote yes or no, and then the, you know, the main treasury will understand at some point that a certain threshold has been met. So there's a ton of different topics and areas we could delve into, but today I'm going to specifically focus on what is the best way to coordinate signatures on chain. So, yeah, so that's what we're going to do. So I put up a little diagram here just to like sort of show you what the main idea is, where each of these black boxes is what we're calling an action. So for example, this one, you know, wants to transfer token. This one wants to mint. This one wants to destroy. And inside of each action, there are different signers that are at play. So for this transfer token action, signer A and signer B have to vote on whether or not they want this to go through. In this mint token action, there is signer A and signer C, and in destroy action, it's just signer A. So the idea is that in each of these actions, you know, there's different signers that have say over that action, right? And then each of these signers, signer A, signer B, can call the respective vote function inside each action to vote either yes or vote no, right? And so I actually have spun up a very simple contract. This is not at all a complete contract and would actually not really work at all. But I've spun up a contract similar to that diagram where each of these black boxes is this resource called Action Wrapper. And it contains the signers, which is basically just these orange signers that I drew right here, the votes that have gone through, and then also a vote function, right? Where someone can call the vote function with an address and a vote. It will first check to see if that address that has been provided is actually supposed to be a signer. So, for example, if signer C were to try to vote on transfer token, it would just not work and it wouldn't go through. And then once that happens, it stores the vote, right? But the crux of the problem here is that this vote function is public. And right now, if I wanted to, I could call this function called borrow action that borrows this action wrapper, resource that's just stored in the contract for now, just to make it super easy. I could, for example, or actually, to make it easier, signer C could borrow the transfer token action, right? And just vote for signer A, right? That signer C could just provide signer A's address and say yes. And then, there's no security around this voting. So, you know, I'm going to cover two ways today that we can get around this, and I'm going to talk about the benefits and the downfalls of each. But is everyone okay so far with the setup of this and sort of like why we're talking about this topic today, or are there any questions about it so far? I'm just going to wait a couple seconds to see if anyone has any questions in the chat. Cool. Thanks, Luca. Love that thumbs up. Okay, cool. So it sounds good. So the first way that we can actually go about this is sort of strange, but I love using this pattern in Cadence. So what we're going to do is we're going to define a resource down here. And for the record, this is the worst way to do it, but I'm still going to show you how to do it. So we're going to define a resource called identity. And this is basically just going to be a resource that users store in their account. So anyone can create this resource and then store it in their account, and I'll show you why. So it's a resource called identity, and in here we're going to have a function called vote, vote on action. And then we're going to provide a vote parameter, which is either yes or no. So that's what the votes are really. It's just either a yes or a no. It's just a Boolean. And what this vote on action is going to do is it's going to first get the action, which is in this case multisig.borrow action, and then we also need the action's ID, so we need to know like which action we're voting on. So I will also provide that parameter. So first we borrow the action, and then what we say is action.vote. And this is why using a resource is so helpful, is the address that we can provide, we can say self.owner.address. And this is why this solution works, is because we can provide an address that we know is stored by this resource. And what we can do with this function now is change this to access contract. That way, no one can publicly call this voting function, right? I can't, for example, or I guess in this case, if we're trying to decide on the transfer token action, signer C can no longer vote on this action, because if signer C were to just publicly borrow this reference, right, they can't call the vote function anymore because it can only be called inside the contract. So the way that it works now is signer A or signer B would create a identity resource, store it inside of their account, right? Then they would borrow a reference to it and call vote on action. And what it would say is, they would provide the action they're voting on, they would provide their vote, and it would say action.vote, and it would pass through their address, right? And in this case, signer C would not be able to do it, because even if they were to store this identity resource, if they were to vote, it would provide, signer C's address here, and it would panic right here because they are not a voter of this action. Any questions on this initial solution? So this solution is a pattern that I use all the time in my contracts, not even just for multi-signing, but I guess this is just like broadly how to get around the message.sender problem in Cadence. For those of you that don't know, message.sender is usually is like a very popular idea in like the Solidity world, which is the smart contract language for EVM, where the signer of the transaction. But in Cadence, you don't, and so you can actually get around that message.sender problem with the using self.owner.address inside resources. So even though this isn't the best solution for the asynchronous multi-signing that we're covering today, it's a very useful pattern in your Cadence contracts, which is why I wanted to show it. All right, I'm going to wait about 15-20 seconds, see if there's any questions on that, and then I'll get into the other solution. All right. Thanks, Jeroen, for those thumbs up. Looks like people are doing good. All right. So that is solution number one. Now, solution number two, and let me just quickly mention the downfalls of this example. The downfalls of this example is that in order to vote on that action, we had to basically make a third unnecessary resource just to determine who the sender of the transaction was. And so it's actually very inconvenient because we don't want users to have to store resources to vote, right? There's minor storage costs or storage implications with that. It also clogs up the contract code for no reason. There's really no reason to have a resource that users have to store in their accounts and also, manage on their own. Even if it's easy to manage resources, it's still an extra thought. And so that's not really the best idea. A better idea is, and let me actually remove some boilerplate here so that it's easy so that we can build it up together. The better solution is instead to have something like a public vote function that anyone can call. However, this time we provide some sort of signature that the user must provide and then we can verify that a specific user signed that message. Okay, and that's a little complicated, but I want to preface this by saying thanks so much to Amit. I see you're here for teaching me actually all about this. It's almost more than a year ago at this point. The code that I'm about to cover is from the Zay Verifier team, which Amit was a part of and also did an awesome job with. So just huge thanks to Amit here. Um, but let's get into it. So what we can do is we can borrow the action, right? And then we can call vote, but we're going to provide some sort of signature, okay? And the function that we're going to use to actually verify the signature, which I think is important to look at first, because then we know what parameters we need to verify a signature, is this function. And I'm not going to actually cover in depth what this function is. If you want to, I'm more than happy to stay afterwards or also to just hop on a call with you separately and cover exactly what this function is doing because it took me a few hours to actually understand, I will admit. But I will cover the main idea. So the idea here is that there's a couple parameters that are important. So ultimately, what you're doing is you're verifying that a certain account address, which is provided right here, signed a message, which is this message, using certain key IDs in their account and produce certain signatures during a certain block height. So it's a long sentence, but I'll say that again. It verifies that a certain account address or signed a message using a certain key IDs in their account that produced signatures during a certain block height. Okay, so a lot to think about, but it's actually really awesome when you think about it. Um, so what we can do here is inside of this vote function, we're going to say let verified equals multisig 2 dot verify signature. Okay, and this is what we're going to use to verify the signature. And then afterwards, we're just going to assert that verified equals true. Otherwise, we're going to abort the transaction. Abort the transaction. Signature is invalid. Okay. Now, the next part here is what actually are all these parameters, okay? And I'm going to try and help you understand that through another diagram. So instead of just sending a transaction with, something like an identity resource, right, where you're storing in your account, what we're going to do instead is something like this, where, let's say this is me, this is Jacob.find, and I have a huge smiley face. I'm going to sign a message, okay? And so this whole section is a message, actually. And let me just put a box around it. So this is the message. The message is a combination of the action's ID, okay? So in this case, the action wrapper's ID, the block height that you're signing the message, and also what's called an intent. An intent is basically like a English written or whatever written message that sort of describes what the intent of this signature is for. And so in this case, it's like a human readable message like mint 10 float token to brtech.find. So we provide this intent because if that intent is in the message, it provides another level of security that what the person is signing is actually what they intend to do. Because again, if there wasn't an intent here, then we could sort of trick the person into signing something that we say to them, oh, if you sign this, it'll mint 10 float token, whereas in reality, it's actually going to mint like 100, right? But in this case, if we know that if this person is actually signing a message that includes a certain intent, then we can prove that this is actually what's happening. And when the user signs this message, it will produce signatures using key IDs that are in their account, okay? And what I will do is I actually want to provide you some code from a project that I'm working on right now in case you want to take a look at it. This function is actually exactly what this diagram is doing. So this function right here, just to dive into it super quickly in case you're curious, this is all in JavaScript. It's taking a intent, which is, for example, mint 10 float token to brtech.find. It's creating a message, which is just represented as MSG. And you can see it's a combination of the action's ID, the intent, and the block height, right? So this line right here is exactly what this box is right here. And then all we're doing is we're saying fcl.currentUser and then signing that message, which produces key IDs and signatures, which is exactly what I've showed you right here. Oh, sorry, right here. And then we're just returning it and providing it to the transaction, okay? So this step is covered basically word for word in this function. And the important part now is to recognize that we return these, these values and provide it to the transaction, which is where we are now. So what you would provide to this function is, like I was showing you, the message, the message, which is a string, the key IDs, which is basically just like an array of integers, the signatures. I'm trying to like show you at the same time I'm writing this, which is an array of strings, and then also the signature block, which I think is a UN64. Yes, it is. All right. So these are the as we see right here, these four things are what we're passing into the transaction: the key IDs, signatures, message, and signature block, which is what I've just provided into this transaction here. And then we need two more variables, which is the UUID and the intent. The UUID is literally just self.UUID because every resource on the blockchain has a certain unique identifier. And the intent is something like self.intent, where we actually store the intent string inside the action. And so you can imagine we say self.intent equals, mint 10 flow token to brtech.find. All right. So I know I've been talking a lot, but what's going to happen now is, and so I'm trying to mute some background noise, is we can call this function, or anyone can call this function, but when they call this function, they have to provide a certain account address, what their vote is, and then also all these parameters that will help us verify whether or not this user actually signed this intent, or the message that they are okay with minting 10 flow token to brtech.find. All right. So are there any questions? I mean, I'm sure there's a billion questions about this, but I'm just, it's sort of difficult to try and condense this into 20 minutes, but I hope that this is making some sense. And I actually will show you a live example of this on a project that I'm working on to maybe help you get a grasp of it. I see Ray has a question, so that's awesome. Um, Okay, that is an amazing question, Ray. Thank you so much for asking that. So I actually never covered that. So I'm so glad you asked. So the reason that we need the block height, well, technically we don't need it. However, it adds a much greater level of security to the signed message because let's say we have an example where, I as Jacob.find say, you know what, I want to mint 10 flow token to brtech.find, right? And I sign that message and I vote on that proposal and I prove that I signed that, right? And let's say I do that on March 25th, which is today. 2 days from now, another action spins up, which is the same exact thing. Mint 10 flow token to brtech.find, right? Um, Now, that's a little bit dangerous because it's the same exact intent, but it's happening on a different day, right? Or like, let's say the previous vote failed, and now we're trying this vote again in the same resource that's happening on a different day. What could happen is someone could provide my signature 2 days from now, right? And that's a little dangerous because, again, even though I've previously signed it, I don't want that signature to be used more than, let's say, 3 blocks in advance, right? However, someone could take that signature that I provided on chain and use it again, some amount of time in the future. And so, the signature block is supposed to basically add more guardrails to not allowing your signature to be used a certain period of time in advance, and make sure that you signed that thing in a, like in a timely manner, or that in a time where you had meant to actually sign that vote. I hope I'm describing that right. So if just to give you a little sneak peek of what that's doing, um, all that's doing is down here. It's just making sure that the signature block, I believe. I actually haven't looked at this in a bit, but um, let's see. I haven't looked at this in a second. Very interesting. We have been using something similar to. Oh, Andrew, that's an awesome question. I'll answer that in a second. Very interesting. We've been using something similar to Cellpack with Flovitar, but the signature is done by the smart contract account actually, and it's a one-time usage. Awesome, Luca. Yeah, that's awesome. Yes, it does, Luca. Actually, I believe you're talking about this one or this right here. Yes, it does work with Dapper Wallet. Andrew, that's an amazing question. So the reason that it's asked that it provides a signature or sorry, an array, and this also is for key IDs, right? You're probably wondering why is there an array of key IDs? It's because some accounts. Okay, so this gets a little bit into account architecture, but I'll try and show you. This is a random. Oh, actually, this is actually let's just use a random. I don't know. Let's say oh, you know what's a really good one is what's that one? Oh, Flowview. Let's use Flowview. Um, let's just use the random account. I don't want to use my account just because it's awkward. But does anyone have a random account they want to use? Actually, oh, you know what? Let's do the flow token contract. What is that? Contract browser. Flow token. Let's just use the flow token contract.
You can also find it in the top and the bottom.
Oh, you can? Oh, thanks,
There's like
Andrea.
the top contracts and in the homepage.
Oh,
FYI.
thanks, Andrea. Let me just paste this into here. Oops. And we'll start searching. Okay. So, oh, well, this isn't a great example because there's only one key, but sorry. Okay, I'll try to explain this. So, each account on Flow can have multiple keys, right? And the idea is that when you sign a transaction, you need to have a total weight of 1,000. It's the same thing when you're providing a signature, right? When you provide a signature, you want to provide a weight of some of 1,000 in order for it to go through. And so you can have multiple keys on your account that have different weights that can add up to 1,000. So in this case, oh, thanks, Andrea, my savior. So it's actually a good thing. So in this example, you can see that this account has one key. Yeah, screw you, Luke. This account has one key that has a weight of 1,000, right? So in this case, when this account signs something, it will be one key ID and one signature. So the lengths of the arrays will just be one. Right? So, however, in this case, because there's multiple keys, right? There's one with 999, there's one with 1 or 1,000. Let's say this account signs a transaction using this key, 999, and this key, 1, which adds up to 1,000, right? Then it will provide two key IDs and two signatures, each from the respective key ID. So then there will be multiple keys. I hope that makes sense, Andrew. And also this is very common with Blockto accounts because Blockto actually you'll usually see this with Blockto accounts. You'll see like a 1 and a 999. But I think if you go self-custodial mode, it actually transfers or some weird tech thing, but rip. Raise your hand if you're wearing an Emerald City shit. That was funny.
No, but I am actually wearing an Emerald City shirt.
Oh, really?
Yeah.
That's
Do
awesome.
you want to see it?
Yes, I do.
All right.
All
Look at
right. I'm showing this on stream. Let's go.
Woohoo!
Woohoo! I love that. Thanks for showing. Awesome. Andrea with the merch. All right, so let's get into a real example now. I'm going to show you. This is basically a sneak peek of our upcoming Toucans platform at Emerald City. But the reason I'm showing this is because it actually is exactly what I've been talking about today with multi-signing. So, long story short, without providing you too much annoying detail about the platform, essentially I've created a DAO called Office Hours DAO. And in this DAO, I have set up a format where there's two signers, this random account and this random account, and the threshold to making an action approve is 2. So essentially what that means is that both of these signers have to say yes in order for an action to go through. So let's say in this DAO, I want to mint, or I want to actually withdraw, let's say withdraw. I have 1,000 flow in this random DAO. This is all on emulator, by the way. I wish I had 1,000 flow. Is to, let's say we want to withdraw to this random account, and we want to withdraw 100 flow token, okay? So I'm going to create this action. So what I'm doing right now is I'm creating a action wrapper. I just created an action wrapper with two signers, no votes yet, and an intent, and you'll see the intent in a second. So inside this actions queue, we can now see that there's an action, right? And if I zoom in here, this is what I've been talking about. So the action ID, right, the UUID that's provided right here is 51. The intent, which is stored right here as a string, is withdraw 100 flow tokens from the treasury to jacob.find. So I just configured that, right? I wanted to withdraw 100 tokens, and this is just hard-coded for now, but this is the intent. And so what happens as the signer is when I click this button, right? So I'm going to be calling, or actually not yet. So when I click this button, I'm going to call this function, this sign action function. So let's try it. I click this button. It's asking me for a signature. Okay, so because it's on an emulator, by the way, the message is like a weird hex string, but in real format, this would say like withdraw 100 flow token to jacob.find. So I can approve this, right? So when I approve this, I'm signing the message, approve, and then it comes up with a transaction. And the transaction is going to take that signed message I just signed, provide it to this vote function in the transaction, and then vote for me, okay? So if I approve this, it's going to seal it. And then if I refresh the page, you'll see that the signatures is now 1 out of 2, and I have voted yes, okay? So now let's go to a different account, the other signer, and I'm going to also on this one say yes, and I'm going to sign it, and then I'm going to send that signature, and I provided another one, right? So I provided another signature. We verified the message on chain. All that cool stuff is happening. And then when I go back to the DAO, the action is no longer there, and you can notice that we only have 900 flow token in the DAO now because 100 was withdrawn to my account because the action went through. And if you're curious about seeing this in like actual like real code that I've made, you can check out this piece of code right here. This is the Toucans contract. And you can see that instead of having like an action wrapper and a vote function, we instead call it a multi-sign action, and we have a decline and accept function. But you can see right here, if I zoom in, that we are indeed using the verify signature function exactly the way that I've described it to you in today's office hours session, with the UUID, the intent, and all that cool stuff. So yeah, and I guess just slight promo here. This Toucans platform is going to be live possibly tomorrow. Woohoo! So yeah, very excited about that, and I hope that you find this all useful. And I also hope that this gave you a understanding of how this is working under the hood. Um, yeah, so I will basically be spending the next 24 hours of my life making sure this platform works, and then hint might be available tomorrow. But yeah, I hope that made sense. I'll pass it back to you, Luke.
Yeah, I love the finish with some super alpha right there. If people don't know about Toucans, where's the best place for them to go to read more right now before the potential release?
Yeah, the best place to go read about it is honestly like this demo link. It doesn't actually like work completely at the moment, which is why after this office hours I'm gonna have to like work out some stuff. But this is a demo link if you guys want to use it on testnet. Um, and there's some like basic information on the homepage here. Or also just if you are really wondering about the project, please head into the Emerald City Discord, and yeah, there's also a demo here that I'll bring up too. Hold on one sec.
All right, awesome. That sounds cool. Feel free to drop invite to the Emerald City down Discord just in case anyone's not in there, but I assume most people are. I mean, you should be. You should be in that Discord if you're listening. Jacob, thank you so much. There is a couple of questions. I'm going to read one from Andrew. Shout out Andrew. He's saying, just wondering, is there any ways that we could do a multi-sign on updating the contract?
Yes, you can, because at the end of the day, updating the contract is a on-chain transaction, so you can do that also. Yeah. I mean, there might be some like maybe some slightly weird things with that, but I imagine that's perfectly doable because updating a contract is just a transaction, in the same way that minting a token or withdrawing a token is a transaction too.
Easy. Look at that. Jacob just bossing through these questions. Now, that was great. Gotta give it to Jacob. Thanks for the presentation. It was clear, it was easy to follow, and it was recorded. So if you want to go back, re-listen to it, or you want to send it to a friend, like whatever it is, Jacob will be sharing that YouTube video, and we'll also be tweeting it from the Flow Twitter account, which I've seen you will follow and turn those notifications on. All right, now next up, I'm going to give a little tease, but you got to keep this tease top secret. So everyone listen right now, what I'm about to say, you're not allowed to share this, okay? But in the coming weeks, we will be having another Flow hackathon. I'm not going to give any details right now. The proper announcement will be happening soon. If you're interested in learning more and getting that sneak peek scoop and figuring out how you can get involved, please do hit me up in the DMs, okay? And I'll be sharing more information in the coming days with people that DM me. And then soon we'll be sharing more information to the wider community as well. But if you want to get that first early news, please hit me up. Right. Is there anyone who wanted to bring up any particular topic in terms of talking about what they're up to, or any questions about building on Flow? We're going to have about 15 to 20 minutes of open floor. So if you have an issue you've run into, or something you want to talk about, or a question for the team, now is the time to ask it. You can either just click unmute and talk away, or you can write it in chat. I'm going to shut up for a sec, though, and let people think about anything they might want to ask or say. Wow. I thought Peter was coming in with a question. Just background noise. I got really excited at Peter.
Maybe we can talk about cool and interesting ways in which something like toucans can be used,
Sure.
regardless of whether you have a DAO or not.
Sure. Yeah. Happy to do that. So I guess why don't I just bring up the page again? Yeah, I'll just and anyone please feel free to interrupt me because this is your time to ask questions, but I will talk about this for a second. So some cool ways that toucans can be used, or which I think it will introduce some cool use cases to the Flow chain, is the ability to, even if you don't have a DAO, right, as of now, you can always found one and manage, funds for your project in a multi-signed way. So, if you, want to spin up, if you want to quickly spin up a project and you want to, have some sort of treasury where you can manage Flow token or USDC, you can do that, and then you could add signers to your DAO and manage it together. That is one thing I'm super excited about. The second cool thing that Toucans does is it actually creates a token contract for you. So with this DAO, Office Hours DAO, I called it Devo. I think I was meaning to make it Dev Office Hours, so I just put Devo. But Toucans, deploys an entirely new smart contract for you. So I really think this is going to be huge for helping to, push forward DeFi on Flow. With even stuff like meme coins and stuff, and all that kind of stuff, where you can create your own token, right? And then you can go to Increment Fi or all these places, create swap pairs. That you own the contract, so you can do whatever you want with it. Um, Another really cool thing that you can do on Toucans is fundraise really easily. So if you want to kickstart a project and raise funds for it, you can issue your token in exchange for Flow or USDC through things called funding rounds. So you can, get your project funded by creating a funding round and having people give you Flow or USDC in exchange for your project's token. Um, so that's also like a super awesome way to kickstart your project on Flow. So those are the three main things I think are going to be awesome.
Sounds super useful. Really looking forward to seeing how the community uses it
Thanks.
and
Yeah.
turns it into a tool. Yeah, cool. So tomorrow, huh?
Tomorrow. Nervous, but
I mean,
tomorrow.
maybe, right?
Yeah, maybe.
It's not guaranteed, but it's likely.
Yeah.
We will do a Twitter Spaces tomorrow about this time as well. So we'll be chatting. Well, it'll be myself representing the Flow team, chatting to Jacob representing the Toucans team to ask him questions and kind of go through it from a very high level kind of introductory point of view. So if any of you want to join that, that'd be awesome to see you. But also, if you've got people in your community, shout out Luca from Flovitar talking about how he wants to use something like this potentially for the Flovitar DAO. That Twitter Spaces would be a great way for your community to get a bit of a better understanding of what Toucans is without diving as much into the sort of hardcore developer technical side of it. It's going to be more sort of high level overview. So definitely recommend sharing that to anyone who wants to learn more. And we'll be tweeting about that within about an hour or so. So there'll be a tweet for you to share with them. Any other questions or topics? If not, we can wrap up in a few minutes.
Yeah, I'm happy to stick around also until I guess it's 11 my time or 12 minutes from now in case people have any questions and just don't want to share in front of everybody. But otherwise, I think we can wrap up now and I'll just stick around for any lingering questions.
Yeah, that sounds good. So thank you everybody for tuning in. It's been really fun running these developer office hours. I think we've had a couple of great presentations. We've had some really interesting questions, and we are seeing people get help that they need. So it's definitely worth doing, which means we will be doing them again. Please stay tuned. I think we'll probably be doing them at least every other week. We might be doing them weekly. And once again,